Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and today we've reached question 20, which reads, if the frequency of the master oscillator in a transmitter drifts, then A, the depth of modulation will vary, B, more signals will change frequency during each DIT and DAR, C, the sidebands on AM and SSB may be inverted, or D, the transmitted frequency will change. Okay, so with this question, the really important terminology here is the master oscillator in the transmitter. And the terminology master oscillator makes us think that everything else in the transmitter is going to be derived from this one oscillator. If we take a look at the full license manual, we've got a block diagram here showing a transmitter architecture. It doesn't matter in particular what this is doing, and we can see here we've got a crystal oscillator which is feeding this modulator and filter, and another one feeding this frequency synthesizer, and we're kind of implying that everything is being fed by another crystal oscillator. So this crystal oscillator maybe is a divided version of this master one over here, as is this one, can be multiplied up or multiplied down, and we have a single oscillator driving everything within this transmitter. So let's run through these answers and see which ones stick. So we've got A, the depth of modulation will vary. Well, if you're with me for question 19, we actually talked a bit about what the depth of modulation and modulation index is, and that isn't really frequency dependent. It's unlikely that there will be an oscillator driving that, so we can scrub that out. B, more signals will change frequency during each DIT and DAR. Now this is quite interesting because we can see how if our oscillator driving our frequency synthesizer, which is feeding our mixer, would change, and we were working CW, we could see how that could cause the frequency to drift along with that oscillator. So that is a possibility. That is a possibility there, that the more signals will change frequency during each DIT and DAR. C, the sidebands on AM and SSB may be inverted. Well, while you would use, say, a balanced modulator to generate SSB, and then you'd strip out one sideband, and yes, there would be some mixing involved in doing that, but you've got to remember everything is being driven from this one oscillator here. This one master oscillator is driving both of these for this particular architecture, and so everything is going to be correct relative to that master oscillator. So yes, the sidebands the sidebands on AM and SSB are unlikely to be inverted because relative to the master oscillator, nothing is changing. It's just the master oscillator itself that is changing. So I think we can scrub out answer C. Or D, the transmitted frequency will change. Well, this is actually quite similar to option B here. So let's look at why there is a difference between these two. More signals changing frequency during each DIT and DAR is actually something that would be observed by the receiver only. So you wouldn't necessarily notice that from your transmitter. It would be the receiver that would perceive those more signals will change frequency. If your master oscillator is drifting, it's changing where you're transmitting at, and for a receiver, if you're changing where you're transmitting out, your DITs and DARs are going to change in frequency. However, this bottom answer, D, is saying that the transmitted frequency will change, and that's not just limited to CW. That could be also for AM, for SSB, for FM, for D star, or whatever else you were doing on that transmitter. It's not just limited to CW. So while this answer does kind of nearly get us there, it's not. Then this isn't necessarily the answer for this question, because while a receiver would observe that happening, it is in fact that's a symptom, and the cause of that is that the overall transmitted frequency is changing because of that master oscillator drifting. Alright, so let's see how we did. Let's take a look at the answers, and we can see, of course, for question number 20, it's answer D, the transmitted frequency will change. Thank you very much. I'll catch you for the next one.